Good morning, good morning, good morning, good morning. Alright, so I think today what we are going to do is I had thought of doing financial maths, but for grade 11s. But you see, the thing is, I don't have a calculator. And if I can trust that people will join that have calculators, then just maybe I might do financial maths. But if not, then I'll do some grade 9 revision work, that's for sure. Right, so currently, let us see. With our grade 9s, what we are doing currently with the grade 9s is at our respective schools. Grade 9 is busy with straight line graphs, and geometry is coming up. So let us look at questions that have to do with that. Straight line graphs, geometry, and then anything else that's related with that, so that we can apply our knowledge of what we are learning to exam type questions. Right, so we are going to be on that exploration, which means tomorrow, grade 11, I'll do financial maths for you, but today I can't, unless someone can reassure me in the comment section that they have a calculator. If they don't, I guess, sorry, grade 11s, no financial maths for you. But if someone in the comment section can reassure me that they have a calculator, then just maybe I may be able to do financial maths for grade 11. So I'm going to wait for 3 minutes. If there's someone that can indicate that they have a calculator in front of them and they will be here for the next hour, then I'll do financial maths for grade 11. But if not, I guess, sorry, I'll just do grade 9 related work. Grade 9 related work that has to do with linear functions and also geometry. So who do we have here? Which grades do we have here? Let's first check that. What grades do we have here? And if there's someone who's here who is in a particular grade, what aspect of the maths would you like to actually look at? Let's check that with the people that are here. Or people that are here are all sleeping. Hello, Nzuza. What grade are you in, and what section of the work in maths is Nzuza struggling with, or Nzuza would like to look at? Grade 8. Grade 8 work. What are you guys doing at school at the moment in grade 8? Okay, so yeah, time is lapsing as I would have thought, but yeah, seems like as I had said. Okay. Yeah, so I think I'll be doing some more grade 9 work then. Guys, I'm gonna look at a past paper here. There's a past paper that I have in front of me here. Grade 9. 2018 final end of year paper, and I only want to look at aspects that have to do with financial maths. Not financial maths, sorry. I want to look at aspects that have to do with functions in grade 9. Okay. Hello, Fanelo Creed. Hello. Thank you, Smart Study, for the morning heart me. I really appreciate it, guys. Guys, there's you see the individual called Smart Study there in the comment section that just extended a heart me. you would do well for yourself to actually make sure that you follow that live creator, because Smart Study has resources for all grades, grade 8 to 12. So if you go on to Smart Study's main page on TikTok, you'll find resources that are tailored to each grade, grade 8, 9, 10, 11, 12. Past papers, material for that particular term. So it would do you well if you follow Smart Study very, very well. So let's follow the man. In my comment section, we have Smart Study there. Just follow that individually. It will do you well to follow that individual. Okay guys, let's look at these questions that have to do with functions, term 3 work for grade 9. You can see the first question says, read the flow diagram and answer the questions that follow, right? So we have -2 there. You can see it's your input value. We know these are our input values. And what we have here is a rule. It's half x plus 2. Now, obviously, this here, it has to do with all the values that are our input x values. These are the values we would come and substitute here. Then here on the right, we have what we call output values. We call these our y values. So these are x values input. This is a rule, all right? It's an expression, obviously. It's an algebraic expression, all right? And it's half x plus 2 with 2 terms. Then this is our output values. Now you are asked, what is the output value in A there? So we have -2, which corresponds with A. 0, which corresponds with 2. B, which corresponds with 4. So when we want to find the value of A, we need to take this input value, substitute it in the place of x, because these are all x values, and then find the output value, which is A. So let's go. So we are going to write down our rule, half x plus 2. And then we are going to actually make sure that that rule is now an equation. Y is equal to half x plus 2, because we are aware of the fact that these x values represent the x that is in the expression. These output values are represented by y. So the rule can actually be written as an equation. Y is equal to half x plus 2. So that's why we write it as y is equal to half x plus 2 now. Remember, we want the output value, which is A, when the input x is -2. So what we are going to do is that in the place of A, we are going to write A. In the place of y, we are going to write A. So we say A is equal to, then we take the x value -2, we substitute it in the place of x using brackets. So we are going to say half into -2 plus 2. You see? But then, what's half of -2? A positive times a negative gives you a negative. And then a half times 2 is 1. Plus this 2, which is -1 plus 2, which gives us positive 1. So the A value is equal to 1. You see? So that was straightforward. We got the A value, all right? When x is -2, the A value is positive 1. Now let's move on. We are sorted. When 0 is x, the output value is y, which is 2. And surely when we check this, a half times 0 is 0 plus 2 gives you 2. So this really is true. Now let's come here. B, which is the x value, we want that because the next question says, what is the input value in B? So that means we are going to now take B and substitute it in the place of x. And then we are going to find B. But we know our output value, which is y, is equal to 4. So we rewrite the rule as an equation again. Then in the place of y, what are we going to substitute? In the place of y, since these are our output value, which represents our y values, we are going to substitute 4. In the place of x, we are going to substitute b. Okay. Then we solve for b. So that means we get b over 2 plus 2. Okay, because half times b is b over 2 plus 2. Right? Remember, this b is in the numerator, so it multiplies with the 1 that's at the numerator. We take the 2 over. When we take the 2 over, the positive 2 changes to negative 2. We get 2 is equal to b over 2. Then we want to get rid of this 2 that's in the denominator. So this means this 2 is our LCD. Whenever we have a LCD, and the LCD, we can clearly see the only denominator that's there is 2 for the equation. So we are going to multiply both sides by 2. This 2 that we multiply by, we multiply in the numerator. So that means it will cancel with this 2. We're left with 1 and 1, because 2 divided by 2 is 1. B is isolated. What's 2 times 2? It's 4. Okay, so that means our value for b is actually equal to 4. Okay, so it's very important that we know how to solve for unknowns in an equation. All right, so that is the value of b. Very, very important. So that answers this question. We've got our 2 marks there, our 2 marks there, simply because we were able to do what we need to do when we ought to do it. Right. Let's turn over the page. Let's go to the next question. Now, the next question is as follows. Use the table below to answer the questions that follow. We have a table here. We have at the top our x values. We call our x values the independent variables, right? The input values or the independent variables. There they are, -3, -2, -1, 0. We don't know what the value is there. We have q, and that's all that we have for our x values. Then for y, which is the dependent variable, okay, y is called the dependent variable. We have -10, -7, -4, -1, nothing, and 8. Then we are asked to find the rule in the form y is equal to. We need to find the rule, and it's 2 marks. So what do we do to find the rule, grade 9s, when we are given these values? Input x values, output y values. How do we determine or find the rule? Okay. Now, I'm sure you can see here that from -3 to -2 to -1, there is a difference of 1. It's like we are adding 1 for our x values. Correspondingly, for our y values, -10 to -7 means that we are what? We are adding 3 each time. So there is a evident constant difference for our y values, and there's an evident constant difference for our x values. So this looks like a linear, it's a linear development, or a linear progression, or a linear sequence. In other words, there's a constant difference for our y values as much as there's a constant difference for our x values. So this is a linear development, or a linear progression, or a linear sequence. So that being the case, it means that we can actually get this equation or rule using our approach of finding a linear equation, right? And the manner in which we would go about it is we can see that because this is a linear sequence with linear terms, we can go ahead and use the linear approach of finding an equation. So what we are going to simply do, very simple here, is that if you look at the -3 and -10 with -2 and -7, I can actually use these as my ordered pairs or my coordinates and then find the equation. in the following way. All right, if I know my work as it relates to linear equations, then it should not be so difficult to find the equation when I'm given the table. So I'm going to suggest a way for this specific problem, because this one, like I said, is a linear equation type question. So let's go and actually write our ordered pairs. So we have when x is -3, y is -10. When x is -2, y is -7. So if we come here, you can see that we can write these as coordinates: -3 and -10, -2 and -7. So we can actually find the gradient using these points. All right, because I can use any of these points, because I've already seen that for my x values there's a linear progression, for my y values there's a linear progression or a linear sequence, which means this can be expressed as a linear equation. So I write my ordered pairs when x is -3, y is -10, when x is -2, y is -7. I could use these two if I wanted to. It should still work out. I could use these two. It could still work out. Okay, so that's still fine. Okay, so if you look at this then, y2 minus y1. Okay, so that means x1, y1, x2, y2. So I want to find the equation of this linear function. Then I can go ahead and say y2, that's -7, minus y1, that's -10, over x2, which is -2, minus x1. Remember, there's a negative sign in the function, so I write -3. Okay. Then -7 minus -10, that's -7 plus 10 over -2 plus 3. Then when I finish off, guys, I'm sure you guys can see 10 minus 7 is actually 3. 3 minus 2 is 1. So that means I have a gradient of 3. So if you write our equation, y is equal to 3x, because remember, in the standard form of a linear function, y is equal to m. M means gradient, which is 3. Now all I need now is the value of c. All right. Now to find the value of c, someone who has a good eye will see that, if we look at this point, 0 and -1, this actually represents my y-intercept, right? 0 and -1. When x is 0, y is -1. This -1 is what we refer to as my y-intercept, our c value, okay? The c value. So it would be easy to just go ahead and say that the equation then is y is equal to 3x minus 1. Because if we have the y-intercept, guys, when x is 0, y here is actually representing the c value, the same c value that we are basically going to be substituting in the place of c for the linear equation. So someone who knows their work will know that, this here represents the y-intercept. Okay, and then we'll go ahead and actually substitute that and find that y-intercept. Okay, all right, so let's see. Zoeey, is Zoeey still here? Yeah, if Zoeey is still here, then we'll definitely look at your what you call it. Yeah, but it just doesn't seem like it. If Zoeey is still here, we'll look at your functions, but if not, then, because remember, guys, I work on demand. I came here on the live and there was no sign of anyone. I asked for the longest time, so seeing as though there was no one, I continued with what I wasn't going to start a topic if the person who basically requested it is not here. Okay, you must also know that. Okay, so we're gonna put this on hold then. All right, but this is also in line with linear functions, okay, straight line functions, so it's also good. Okay, Zoeey. Grade 10 functions. Question is, okay, Zoeey still here. Okay. Functions, grade 10. Zoeey, hopefully in summary, you know that in grade 10, we have a linear function, okay, which can be written in the form y is equal to mx plus c, or sometimes people write it y is equal to ax plus q, Zoeey. Okay. Now you should know that this here stands for gradient. That there stands for the y-intercept. That here, that c value, when you let x be equal to 0, the corresponding y value is the c value, which is the y-intercept. Okay. So when you let x is equal to 0 in your function, then the corresponding y value is your c value. So whenever you have coordinates where x you know is 0, that value that you have there is your c value, which is supposed to be substituted there. Okay. Then as far as the gradient is concerned of a linear function, the gradient can be manifest in 4 ways. When the gradient is positive, you have a increasing linear function. When the gradient is negative, you have a decreasing linear function. When the gradient is equal to 0, you have a straight line, which is horizontal. And then that means the y value is constant. Or when we say y value is constant, we mean the y value is the same. When m is undefined, which can happen, the gradient is undefined, you have a vertical line like that. Okay, so that means who is constant here? The x value is constant. And the form of this function is always x is equal to whatever the constant value is. Just like here, when the gradient is 0, we say y is equal to whatever that constant value is for y. Because if your gradient is 0, it means the y value will be the same throughout that horizontal line. If your gradient is undefined, you have a vertical line, it means your x value will be the same throughout that vertical line. Okay. So that's important for your linear functions. And these are like the basic fundamentals that you need to know when it comes to linear functions. Okay, your y-intercept, which is c, and your gradient, which is basically manifest in one of 4 ways. So you need to see the line that you draw whenever the gradient is in this form. And please guys, this here is your standard form of a linear function. So when m is positive, this is your sketch. When m is negative, as a grade 10 learner, this is your sketch. When m is equal to 0, your horizontal line, m is undefined, that is your situation. Okay, so that is like a summary of linear function. Then we have in grade 10 your quadratic function. The form of the quadratic function is y is equal to ax squared plus q. Okay, a here tells us the shape of the function, whereas q tells us it's the y-intercept in grade 10 as well as the turning point. So the y-intercept together with the turning point. So it's one of 2 things. Okay, your q value. Okay, so a will tell you the shape. So in other words, when a is greater than 0 for our quadratic function, we say the parabola is what? Is smiling. In other words, it's concave up, right? With a minimum value. Okay, and then when A is negative, it is said we have a concave down, with Q, which is the y-intercept, being a maximum. All right. Yeah. And then there's something else that I think obviously we need to note, and that has to do with the range. Now, you know as well that the range of a function is talking about the possible y values where the function exists. In other words, we say range is the possible y values where our function exists. And when we look at y values, we're looking from the bottom to the top. So if you're looking at a function like this that is smiling or that is concave up, when we talk about range, we are looking from the bottom to the top. Where does the function exist from the bottom to the top? So that would always then mean that your range for a smiling graph, if you know what the y-intercept turning point or the minimum is, it will always be y is greater than or equal to whatever the minimum value is. Okay, why are we saying y is greater? Because the function is situated at q and above q. So greater than means above the q value. Okay, but equal means at the q value. Okay, so if you know the specific value of q, then you are going to say y is greater than, let's say if you know that the minimum or the y-intercept, let's say here is -3, then you would say y is greater than or equal to -3 if your function is smiling or concave up like this. So this is your range, your possible y values where the function exists from the bottom to the top. Okay, no, it's not my network, it must be yours. All right, my network is pretty good, Zoeey, so it must be yours. I have good connection. So it's not my network, it definitely is your network. Okay, unless there's other people that can tell me that it's my network in the comment section. But Zoeey, it's your network. Unfortunately, it's yours, it's not mine. Mine is actually registering as good at the moment. So unless there's other people who can complain and say, I say your network is not networking, then I'll see what is the problem my side. But it's just that from what I'm looking at, my one is saying good connection, good network connection. So who else is saying they are having problems with hearing me, or the network is not good, or something like that? They can let me know, please, in the comment section. I really appreciate it when people can notify me of such things. The thing is, mine was never off. Mine was fine all the time. So it must be yours. Okay. So like I said, guys, so did you hear what I said here about your parabola or your quadratic function? When a here is greater than 0, okay, then you're talking about a smiling graph, concave up, okay, your range will be y is greater than or equal to this minimum value if you are writing your range, okay, because your range is the possible y values where the function exists from the bottom to the top. When a is less than 0, it's a different story because we are having a concave down function or a sad face, okay. That means that when we write down the range, y is less than or equal to q, because the function is situated below the maximum. So it is situated on that maximum value. That's why we say equal, okay, because the graph touches the maximum point, but it is also situated below the function. Okay, so that's why we say when we write the range, we say y is less than or equal to whatever the maximum value is. So when you know the specific maximum value, then you say y is less than or equal to whatever that value is. And remember, I said that value is represented by your q value. Okay. All right, so I hope that makes sense. In the same vein, there's this thing that we refer to as domain. Domain of a function, whatever function it is, domain means the possible x values where your function exists. That is what we refer to as domain. So when we look at domain, we are looking from the left to the right. And if you are talking about from left to right, you are not dealing with y values, you are dealing with x values. From left to right. Okay. Now, if your function is unrestricted, then we always say the domain for a parabola is x is an element of real numbers, or we can say x is an element of negative infinity to positive infinity for our what? Our parabola. Because if we look from left to right, because remember, these arrows indicate that the function will continue to exist infinitely. It goes on and on and on and on, which means from left we are coming all the way from negative infinity, and then it passes, it turns here, it goes on and on and on and on. So it means the function will continue to exist everywhere on the right. That's why we say, we can either say x is an element of R. In other words, this means that our function exists for all, R means for all real numbers of x. All real numbers of x. So from left to right, the function exists. Or we can write it as x is an element, open brackets, negative infinity to positive infinity. So it's really up to you how you want to write the function. In the same way, we can write the range in interval notation and say y is an element, and then we say square bracket to include the what? The minimum value from the bottom to what? To the top. Do you see? We use square brackets to show that we are including the minimum because the function touches the minimum. So we say y is an element of square bracket q. So if we know the specific q value, we write it to what? To infinite. From the bottom to the top. From small to big. We always write our range from small to big. So there's two ways of writing the range. You can either write it in inequality form, or you can write it in interval notation. This is what we call inequality form. Then this is what we call interval notation. It's up to you how you want to decide. Or if we are looking at this function, the one that is having a maximum, you could write the range in this way: y is less than or equal to q. Or you could say y is an element of, now you can say from the bottom. Where are we coming from? Where are we coming from? You see the arrows going infinitely. So we are coming from open brackets from negative infinity to where? To the top, which is what? Q. And that Q value, since we touch that maximum, it means we are going to include the Q value. So these are two ways of writing the range. Either write it in inequality form or interval notation if you are concave up, or you can write it in inequality form or interval notation. So this is our understanding of the function, guys. Okay, A represents the shape. A greater than 0, we have a smiley face. A less than 0, we have a sad face. With the smiley face, the Q value represents the y-intercept, our turning point, which in the smiling face, the Q value is the minimum. But for the sad face in grade 10, the Q value represents the maximum. Okay? So I hope that's clear. Then the range, like I said, is our possible y values where the function exists from the bottom to the top. Okay, so we're looking from the bottom to the top. So that's why we are looking from q, the minimum, to the maximum, to the highest point, which is infinity. Okay, so infinity just shows that the function goes on forever. This is not in actual fact. This is a representation of the function going on forever and ever. in the positive direction for y. Then here, this is a concave down function. Y, we say here, is an element of from negative infinity to q. Okay, so that's very, very important. Tsepang, I think you are just here to funny things, and I don't appreciate people that just come here and comment unnecessarily because they prove to be a distraction. Okay, all right, so that's just a summary of quadratic functions, okay, when it comes to the concept for a grade 10 land. And guys, here's another thing. In grade 10, your parabola function in grade 10 is always symmetrical along the x-axis. What do we mean by that? In grade 10, our parabola is never going to be moving left and right. Our parabola in grade 10 is always having a line of symmetry, which is the y-axis. Okay? So that means, if for instance we know that the x-coordinates here are 2 and 0, even if you don't know what this point is, you can know what it is, because if this is symmetrical along the y-axis, as a grade 10 learner, your function is always like that. It's symmetrical along the x-axis. So if this is 2 and 0, it goes without saying that this side is negative 2 and 0. Okay? Always, guys. In grade 10, your parabola is restricted. Okay? Yeah, it is very true. So in grade 10, your parabola is restricted along the y-axis. And therefore, it's always symmetrical. Always in grade 10. The function for your parabola is always symmetrical. Things will only change in grade 11 and 12. But for a grade 10 learn, this is as much as you want to know, which is why your function is always y is equal to ax squared plus q. And that is why this here is not only just your y-intercept, but it's also your turning point in grade 10. Your q value. This here, this q value, okay? Okay, very important. This q value is your y-intercept, but it's also your turning point. Okay? Very important. Okay? So I hope that's very clear for all grade 10 learners. You know, and then sometimes you're asked to find the equation of the function. You're sometimes asked to sketch the function. If you're asked to find the equation of the function, then there's two situations or scenarios that they love having, and that is when you are given the x-intercepts and one other point, or in a situation where you are given the turning point and one other point. Okay, and the approach to answering those questions differs according to the situation. So that's just a summary on quadratic functions. Now I want us to step into the world of hyperbola, okay, because I'm just doing a summary here so that we have a roundabout idea of the functions. So in grade 10, your hyperbola function, once again, is limited to y is equal to a over x plus q. That's it, okay? And yeah, y is equal to a over x plus q. Okay, so our hyperbola is restricted to y is equal to a over x plus 2. What do you want me to re-explain now? What do you want me to re-explain? The Ndebele girl, what do you want to re-explain? What do you want me to re-explain? Okay, guys, I have limited time here, so if you... The quadratic. Okay, so here I said that the quadratic function is given by the form y is equal to ax squared plus q. Okay, the a helps us to see the shape of the function. Okay, so if a is greater than 0, you have a concave up graph. In other words, a smiling face, right? It's like a smile, right? The q value tells us about the y-intercept and the turning point. Okay, so our q value is going to be situated as the y value that is here. It is the minimum when a is greater than 0 because it's a smiling face. But when a is less than 0, it is the maximum. Okay, so whatever that q value is will be represented by our y-intercept. Okay, there. Minimum when a is greater than 0, maximum when a is less than 0. So if this a value is a negative value, we know it's the maximum. When this a value is a positive value, then obviously the q value will be our minimum value. Then I spoke about range. The range of a function is the possible y values where the function exists from the bottom to the top. So for the parabola here, if we look from the bottom to the top, where will the function exist? The function will exist where y is greater than this minimum value, which means above, and you can see that the function really is above this q value. Greater than means above, and it's also existing where the function is on the q value, which means equal to q. So this is how we would write the range. But if we know the specific q value, obviously we're not going to write q. If this was 2, q was 2, then you would say y is greater than or equal to 2 for the smiling guy. Or we could write our range in interval notation and say y is an element. Okay, in other words, the function exists for y from q, meaning from the minimum all the way up to the, obviously, to the top, endlessly. Infinity. Infinity means forever and ever above q. The function will exist forever and ever above the q value. The function will exist. So we use square brackets to indicate that our q value is also included in our answer. Okay, then we use open brackets because infinity is not a number. It is a concept that tells us that numbers go on forever and ever. So in the positive direction for y, the function goes on forever and ever. So we write open brackets and we write infinite. Okay. Then for a sad graph or a concave down graph, when a is less than 0, the q value, which is the y-intercept in grade 10 people, represents also the q value for our y-coordinate of the turning point. So y is less than or equal to q. In other words, this less than means the function is below. Less than means below the maximum, below the q value. So the function is found below the q value, below the maximum. And on, equal, on the q value, on the maximum. We can write the range as y is less than or equal to q. If we don't want to write it in inequality form, we can write the range in interval notation. Where is the function coming from? This here arrow represents we are coming from the negative values, which is negative infinite, all the way to what? The q values. The q value is your maximum. Okay, very important, your maximum q value. Okay, so that's why we include the q value, because we arrive at the top, it's on q. So we say square bracket. We open bracket for negative infinity, because when we say negative infinity, forever and ever from the negative values of y all the way to q. That is our range. So this is generally how we try and understand the form of the quadratic function. Y is equal to ax squared plus q. When we have the standard form, we can talk about a, we can talk about q in the following headings. Okay, right. Then I spoke about domain. What is domain? Domain is the possible x values where the function exists. I repeat, domain is the possible x values where the function exists. We know that the function will exist from left to right for our domain, because x means from left to right. So from left to right, the function is unrestricted. Okay, from left to right, our function is unrestricted. Why do we say unrestricted? Because it exists everywhere from left to right. But we just simply write x as an element of real numbers, because from left to right, x is an element of real numbers. Or we can say x is an element from negative infinity to positive infinity. Okay, so I hope that makes sense. Right. Yeah, so that's what I was explaining about quadratic functions in summary. This is not everything there is, but this is just a summary so that people have an idea of what we mean by a quadratic function. Okay, yeah, and then I was just speaking about this thing that the quadratic function is always symmetrical along the y-axis. Remember, guys, that the y-axis has an equation which is x is equal to 0. That is the equation of the y-axis. Now, if you know that your coordinates this side are 2 and 0, it is very easy for a grade 10 learner, to know what the coordinates are for the left-hand side. Because if this is 2, then this stands to reason that this is negative 2. If this was 5, it would make sense that this is negative 5. As long as we are in the same horizontal line, the x coordinates, okay, will give us the same value with different signs. Are you with me? The same x value but with different signs on the same horizontal line. Guys, it's like if I knew what is happening in this horizontal line. For instance, if I had a horizontal line here, let's say the equation of this horizontal line was y is equal to 5. Okay, I know that my y values will be the same everywhere on this horizontal line. Okay, if this here I know is 7, for instance, the x coordinate I know is 7. Let's just say, for argument's sake, the x value for this point is 7. Then obviously the x value here would be negative 7. I hope that makes sense. Okay. So because why? Because the function is symmetrical along the y-axis, right? So on the same horizontal line, we'll be getting the same x values but with different signs. The same x value but with different signs. My y value obviously is going to be the same throughout this horizontal line, but different x values with different signs. Same x value with different signs on the same horizontal line. When you know those things, it makes perfect sense for your function. Right, now I'm going to move on to the hyperbola. Hyperbola function, guys, is a interesting function because it has something that we refer to as asymptotes. 2 of them. Your hyperbola has 2 asymptotes, in grade 10. One of the asymptotes is always based on this. Guys, what value, what can x never be? There's a value here, if I substitute, will lead to my equation or my function being undefined. What should we always make sure x is never going to be here in the denominator? What value should we never have here in the denominator? Okay, Zoe, very true. We can never have 0 in this denominator. So, that being the case, guys, one of the asymptotes that we have, what is an asymptote, by the way? Asymptote is a boundary line where the function does not exist. What is an asymptote? It's a boundary line where the function doesn't exist. Okay, it's like you as a grade 10 learner, you must also have boundary lines. You must have boundaries. You must have boundaries, because if you don't have boundaries, you're going to have problems. So a hyperbola does not exist if it does not have these boundaries. There's 2 of them. When those boundaries are in place, then this function can exist. But those boundary lines basically indicate where the function should never exist. Okay, 2 of them. So we have the horizontal asymptote and the it means that asymptote is a horizontal line, which means it will be given by the equation y is equal to whatever the constant value is on that horizontal line. So the horizontal asymptote, guys, will always be given by y is equal to q. Which q value are we talking about here? We are talking about the same q value that comes from the exponent, the hyperbola equation. So this horizontal asymptote, if I know the specific q value, my horizontal asymptote is always y is equal to whatever the q value is when the hyperbola function is in standard form. Please, guys, this equation first must be in standard form. In other words, y is equal to a over x, whatever the a value is, plus or minus whatever the q value is. When you have this form, the equation of the horizontal asymptote can be written. And it is y is equal to whatever that q value is. Okay, are we together? That is the horizontal asymptote. It is a horizontal boundary line. Okay. Then there is the vertical asymptote. In grade 10, I just asked you guys now, what can x never be? You guys said, say, x can never be 0. So that being the case, the vertical asymptote is a vertical boundary line. In grade 10, it is always the y-axis, which is given by the equation x is equal to 0. So our vertical asymptote in grade 10 is always x is equal to 0. Guys, this only applies to our hyperbolas in grade 10, because in the grade 10 syllabus, the function for the hyperbola is restricted. Okay, it is also restricted. Okay, so vertical asymptote always in grade 10. If you are a grade 10 learner, then when they ask you what is the equation of the vertical asymptote, you look at the denominator for the equation for your hyperbola function. It is clear that x is alone. It is not accompanied by anything else. So you take this x, you equate it to 0. That is your boundary line for the vertical asymptote. Where? In grade 10, not in any other grade. So if you are a grade 11 learner and you are watching this, if you are a grade 12 learner and you are watching this, you will know for sure that in your denominator, your function does not just have x, it has something else. So then you have to take that whole entire thing, equate it to 0, solve for x. That is your vertical asymptote in grade 11 and 12. But in grade 10, we don't even think. We know our vertical asymptote. X is isolated. What can x never be in the denominator? X can never be 0. So the vertical asymptote is x is equal to 0. Full stop. Okay? So two asymptotes. Horizontal asymptote, y is equal to q. Where do we get it? Whatever the q value is, when the equation is in standard form. Vertical asymptote, where do we get it? We get it from the denominator. What can x never be? It can never be 0. In which grade? Grade 10. I am speaking to grade 10s here. So please. Yes, Zoeey, that's what I'm saying to you. It's always like that. In grade 10, if you are doing caps, grade 10, I'm not talking about IEP learners here. I'm talking about grade 10 caps learners. Then that is always the vertical asymptote. Okay. So I hope it makes sense. So yes, it always like that for grade 10. Okay. Now, let's look at the components that make up the function. We have a mos, right? A, when a is greater than 0, your hyperbola function, guys, remember, what did I say? I said that your y-axis is always our vertical asymptote in what? In grade 10. But now, I am going to do this, all right? Y is equal to q. Reese Swindle, that's fine that they are at school. They can always go to my YouTube channel, because I upload the live lesson that I've done in the YouTube channel. The link is in my bio, so they can rewatch or they can watch the lesson whenever they are ready to do so. So chill, Reese. Chill. Those who are here are here. Those who are at school are at school. Those who are here benefit. Those who are at school benefit later when they rewatch in the YouTube channel. So chill. Okay. So guys, what you are seeing me do here is that as I am going to be sketching, I draw in my y-axis as a grade 10 line. Obviously, you would also draw in your what? Your x-axis. But guys, there's two reasons why I drew in my boundary lines first. My y-axis, remember I said the vertical asymptote is always going to be x is equal to 0 for a grade 10 line. Then your horizontal asymptote, there it is, my boundary line, okay? Remember, your boundary line needs to be represented by these, these lines that are like that. Yes, of course, this is my x-axis, okay? This y-axis is also a boundary line. Now, if a is greater than 0, your function for your hyperbola is found in two quadrants. Now, let's define what quadrants are as a grade 10 learners. When you have your vertical asymptote and your horizontal asymptote drawn in to your function, these are your quadrants. Your graph, when a is positive, is found in the first and second quadrant. Our quadrants are defined according to the asymptotes. It's the asymptotes that give us direction as to which are our first and second quadrants, third and fourth quadrant. Guys, a quadrant is simply this. You see from this vertical asymptote to this horizontal asymptote, this is what we call quadrant 1. From this section, okay, that's quadrant 1. This is my asymptote. This is also my vertical asymptote. This is quadrant 1. So my function is found in the first quadrant, and look at my when a is positive. Okay. Then it is also found in the third quadrant. No, first and third. Sorry, I said first and second. First and third. My mistake. So when a is positive, my function is found in the first and third quadrant. So look at this here. This is my first quadrant. This is my second quadrant. This is my third quadrant. This is my fourth quadrant. So when a is positive, you can find your function sketched in the first and the third quadrant. This is very important. When a is positive, when a is greater than 0, your function for the hyperbola, because your hyperbola has 2 arms, all right? Please, guys, these are nice, smooth curves. This curve approaches the asymptote that's vertical, but never touches it because it's a boundary line. Guys, when you have boundaries, you don't play close to, you don't play on your boundaries, okay? Because those are like no-go areas. So this is a no-go area. So this function will never ever touch this vertical asymptote. Just like here, it curves, but it will never ever touch this horizontal asymptote. Same likewise here. This is a nice smooth curve, but it will never touch the vertical asymptote. And this is a nice smooth curve. It approaches this horizontal asymptote, but will it ever touch it? No. Asymptote, never. It's a boundary line where the function doesn't exist. Okay, so I hope it makes sense here. The vertical asymptote, which is x is equal to 0, the horizontal asymptote aligned according to what the q value is. Okay, so when a is greater than 0, your hyperbola is found in the first and the third quadrants. Okay, now what about when a is less than 0? Guys, if the function when a is greater than 0 is found in the first and third, can you guys tell me where do we find the function if a is less than 0? First and third, so my odd quadrants. So when a is greater than 0, my odd quadrants come into effect when a is greater than 0. First and third, when a is greater than 0, my odd quadrants, odd numbers, 1 and 3 are odd numbers. Okay, that's why I'm saying odd quadrants. So it's not first and fourth. Okay, please check again. So when a is less than 0, okay, no problem. So when a is less than 0, guys, again, what do? We know our y-axis is going to be our vertical asymptote. Okay, if you have your x-axis, obviously your x-axis, but remember, guys, you always check where is your q value. If it was negative, then obviously we are talking about a q value that is negative. It would be below the x-axis. Okay, then our quadrants, now you see our quadrants slightly different, because this is our first quadrant, right? Please, guys, we use our boundary lines to define the quadrants. So remember, here our horizontal asymptote was above the x-axis, so that meant our first quadrant is here, our second quadrant is here, our third quadrant is here, our fourth quadrant from here to the fourth quadrant. Now look at here, right? When our horizontal asymptote now is below the x-axis, first quadrant all the way. This is the first, this is the second, this is the third, this is the fourth. Are you with me? So if we are now having a being less than 0, I said which quadrants do we prioritize? A less than 0 means the even quadrants, our even number quadrants. That means the second and fourth quadrants. Okay, so that means our function second and fourth, okay, of course we would, second, and this is the fourth. Okay, smooth curve, guys, curve. Curve, right? This is where we would find, this is basically how our function would be represented. Okay, yeah, I hope that makes sense, and I hope you guys understand. So please always check when your equation, your function for the hyperbola is in standard form, what is the situation with your a value? Is your a positive, okay, or is your a negative? I'm going to show you a specific example just shortly, okay, on how to sketch it. Okay, yeah, and then very quickly I want to speak about the domain and the range of this hyperbola function. Then I'm going to do an example and show you how to do it. Okay, it's just that, guys, unfortunately, you see, I'm not going to be able to stay here for long, because literally I have to get out of here 22 quarter to the latest. I have to leave, unfortunately, because I have work to go to. Okay, so if we look at the domain and the range for these functions, range, okay, where does the function exist from the bottom to the top? Remember, we said range. Range applies for everything. It's the possible y values where the function exists from top to bottom. So this function here, it will exist everywhere from the bottom to the top, okay? But except one place. Remember, on the asymptote, the function does not exist. So the function exists everywhere, because you can see this arrow comes from the bottom, arrives to the asymptote, takes it up again to the top all the way, but it does not exist on this y value because this is the asymptote. So when we write the range, we say y is an element of real numbers to show that the function exists everywhere. But then we write a condition, y cannot be q. So whatever that q value is, we say y cannot be. So if we know this is 2, we say y cannot be 2. If we know this is negative 2, we say y cannot be negative 2. I repeat, when we write down the range, the possible y values where the function exists from the bottom to the top, we know that the function exists everywhere from the bottom to the top, everywhere, except where? On the asymptote. The function exists everywhere except here. Y cannot be found here on this horizontal line. So that's why we say y is an element of R. Okay, I usually say this ER, element R, for learners, just know the word everything. Y, for all y values, for everything that is y. Okay, I usually say to learners, this is like everything. everything. So just this ER, element of real numbers, just know that this is Y available for everything. So we say Y is an element of R to show that the function exists everywhere for Y, but Y cannot be, it cannot be the horizontal, cannot be this Q value. The function cannot exist here. Okay? So that's the easy way of writing the range. Okay, just straightforward. Y is an element of R, Y cannot be Q. Okay, what about the domain? Remember guys, when we talk about domain, we are talking about the possible x values where the function exists from left to right. So if we look at this function from left to right, you will remember we said that the vertical asymptote is x is equal to 0, which means the function cannot exist on the y-axis, which is x is equal to 0. So we write the domain for a hyperbola. We say x is an element of R. So from left to right, from the left, don't exist, to the right, it means the function exists everywhere for x, but x cannot be 0. This is the domain always in grade 10 for a hyperbola function. Okay, all right, guys. I hope me summarizing this the way that I have makes sense for especially for Zoeey, because Zoeey was the one that was asking for functions where these questions are concerned. So our range from the bottom to the top, Y is an element of R, Y cannot be Q, whatever the Q value is, that's the range. The domain from left to right, X is an element of R, but X cannot be 0. You know, that's very important. So I am now, I need to at least look, I'm going to look at a specific question about sketching for all three functions. Before I leave, I just want to now touch on a little bit. Like I said, the domain part, X cannot be 0, X is an element of X cannot be 0, only applies to grade 10. Okay, for grade 10, this is always the case, X cannot be 0. But for grade 11, you have to always check your denominator and check what the asymptote is for your vertical asymptote. Okay, so just be a bit careful, okay, because I'm teaching grade 10s here, and there are specific things that I'm saying to them because it applies only to them. Okay, then I want to just explain the exponential function, and then hey guys, that's if I'll have time to do a question. Okay, like I said, I'll be late for work if I don't leave at 2:15. Okay, or yeah, 2:15 the latest. Exponential function. The form of an exponential function for grade 10 is this: ab to the power x plus q. Please guys, understand, it's ab to the power x plus q. All right, now listen to me, and listen to me well. This here is very, very important, what I'm about to share with you. B can never be 1. All right, B can't be 1. Right, that's very important. Okay, now our exponential function has one horizontal asymptote. Exponential function has a horizontal asymptote. Okay, and that horizontal asymptote is also given by our Q value. There's no vertical asymptote with an exponential function, so that's very important to note from the get-go. So if you look at an exponential function, okay, I'm just going to say or pretend that this is y is equal to q. This a and this b will tell us about the shape and the position. A and b work together, telling us about the shape and position of our function. And I will show you now the different combinations of a and b for our function. So the first thing you need to note very seriously, okay, is when a is greater than 0 and b is greater than 1. When this is the case, the function a is greater than 0. Now I need to explain something. When a is greater than 0, we say that the function is found above the asymptote. Remember, I said, guys, there's only one asymptote and it's horizontal for your exponential function. So when a is greater than 0, a greater than 0 means function is found above the asymptote. If a is less than 0, it means that the function is found below the asymptote. You need to get this. That means when a is positive. Here it means when a is negative. This is for your exponential function. So when a is greater than 0, the function is found above the asymptote. That's why I was speaking about that a and b work together for our shape and position. Okay? So I'm going to show you 4 scenarios. So if this is the asymptote, a is greater than 0, whilst at the same time b is greater than 1, you can expect this shape. Function is increasing. It is a curve that increases like that. A greater than 0, whilst at the same time b here is greater than 1. Okay, anything that's greater than 1, guys, means 1, 1, 1, 2, anything above 1. That is your shape and the position of your function. It's found above the asymptote, as a greater than 0 suggests, but then it will increase above the asymptote. That's one situation. Let's look at another scenario. Okay. Oh, thank you so much, Miss Him. Oh my goodness, it's been a while. Y is equal to Q. Okay. Now, when a is greater than 0, but b is between 0 and 1. In other words, it's a proper fraction. So there's a combination when a is greater than 0 and b is between 0 and 1. How does the function look like? It's above the asymptote, but it is a decreasing function. It's a decreasing function like that. Okay? So a greater than 0, staying true that a greater than 0 means above the asymptote. A greater than 0 means above the asymptote. Okay? Now, the 2 last scenarios. Okay, let's just say the asymptote now was below the x-axis. Still, if a here now is less than 0, but b is greater than 1. Okay, this means below. Remember, a less than 0 means below the asymptote. So that means our function will not be found above this asymptote. It will be found below the asymptote because a is less than 0. But then, very interestingly, it will be like that. Okay. And then when a is less than 0, but b is between 0 and 1, which is the last case and scenario, then our function will be, again, situated where? Below the asymptote. But, how will it look like? Below the asymptote, it will be like that. Okay, guys, these scenarios are very important. So once you know, when you look at your function, you know what the a value is, you know what the b value is, and when you know those a and b values, you simply look at them and you will know how your sketch will be. Once you know the condition of a and the condition of b. So when a is greater than 0, guys, for an exponential function, we are saying the function is always situated above the asymptote. But when a is less than 0, we are saying the function is situated below the asymptote. If the combination is a greater than 0 and b greater than 1, that means the function is increasing above the asymptote. But if it's a greater than 0 and b is between 0 and 1, okay, and by between 0 and 1, guys, if the numerator is smaller than the denominator. That's what it means being between 0 and 1. The b value is between 0 and 1 if that is the situation, okay? So that would be a decreasing function. But if a is less than 0 and b is greater than 1, then it is below the asymptote as a less than 0 suggests, but it is like this. But if a is less than 0 and b is between 0 and 1, then it's still going to be found below the asymptote, but it's going to be like that, okay? Then guys, when it comes to range and domain, it's simply straightforward, okay? Okay, cause remember range we are saying it's the possible y values where the function exists. So I'm sure you guys can see that the function here is existing above the asymptote only. It's not touching the asymptote, it's above the asymptote. So if we write down the range here, we are going to say y is what? It's greater than who? Than q. No equal sign because the function does not exist on the asymptote. We just say y is greater than q. All right. Someone else, if he wants to write it in interval notation, will say y is from q, open brackets, to infinity, open brackets. Okay. Y is an element of from q to infinity. Okay. So there's two ways of writing the range. You can either say y is greater than q because the function is above the asymptote, or you can say y is an element from q, all right, but you're not including q. That's why we use an open bracket to open to infinite. Okay. Then of course the domain on the other hand, domain x is an element of real numbers. The function is going to exist everywhere from left to right. It is unrestricted. From left to right the function will exist because there's no asymptote. There's no vertical asymptote. There's no boundary line that stops the graph from left to right. This is going to go on infinitely in that direction, go on infinitely in that direction. So we can say x is an element of real numbers. So y here is greater than q for the range because the function is found above the asymptote. But then we say the domain is from left to right, x is an element of real numbers. Okay. Then here, okay, range, obviously the function again is found above the asymptote. So it would be no different from this one. Y is greater than q. Then the domain from left to right, x is an element of real numbers. Straightforward. Straightforward. This one, function is found. Is it found where? Below. It's not found above. It's nowhere here. So we say y is less than q. Guys, this thing here just simply means when you say y is less than q, we're saying y is below, meaning the function is below q, below this q value. Y is below this q value. So our range here is y less than q. Or if you want, you can say y is an element, open brackets, negative infinity to q, open brackets, from negative infinity to q. But we say open brackets because we don't include q, because the function does not touch the q value. So we say open brackets, all right? Yeah. Then likewise here, the range y less than q. Okay, yeah, the range. Or if you don't want to write it like that, you can say y is an element from negative to q. All right, but guys, you know most, you will know the specific q value. So guys, don't write q, okay? Because I know some people, they write q. No, you write the specific value that you have there. All right, and then your domain is x is an element of real numbers. Not a problem. Okay. Yeah, so that is the note summary of the functions. Okay, obviously this is not everything, but it is so that we have an idea, all right, of what the functions look like. Now listen to me, guys. I unfortunately have to go. If I don't leave now, I'm going to be late at work and there's going to be a problem. Okay, so I'm very sorry that maybe I was not able to touch everything, but what I will do, okay, Zoe, you're going to have to write today with the limited amount of help that I gave you. It was not full on help, but had Zoe maybe messaged me earlier, like maybe earlier, and told me and said, sir, I have a problem. You guys need to also just make it your priority to actually, if there's something that you need assistance with, or I can do a live lesson early in advance. We as black people need to stop being people that do things last minute or before 2 days before an exam or a test. If we know ahead of time that we are writing, we need to make it a point that we prepare way ahead of time. And we don't prepare by doing everything all at once. I know, Zoe, you did. But the thing is, it was too late yesterday, right? Remember, when you asked me to help you out, you asked me to help you out when I was helping out someone else doing some other topic. I couldn't do anything about what I was doing yesterday. I could only do the topic, right? Remember also, I am not your primary maths teacher. Your maths teacher is at school. Your primary maths teacher is at school. Me, I'm just here to help and assist when I can. So don't use me as your primary vehicle unless you want me to be your primary vehicle. I can help you out consistently, all right? But you need to talk to your folks about that assistance and that help. I can be available to you 24/7, literally, Learners that I've availed myself to 24/7 have my WhatsApp number, and they know I can assist them at any time, any day, anything. All right. So if you want that kind of help, speak to your mother about possibly paying a certain fee, but we have to talk about that, obviously, and then I can help you out consistently and help you out monthly, if that makes any sense. And then you can get the assistance that you need when you need it. Okay. So do then speak to your parents about it, and then you can message me, and then we can talk about it, and then I can make certain things available to you, and then I can be available to you. All right. Because maths, guys, if we are going to do justice with maths and we want to get excellent marks, it has to be daily bread. It has to be daily bread. It cannot be this once-off thing that you do just about when you're about to write a test. You are forever going to get mediocre marks if you go about it that way. Me, I'm dealing with learners that are, especially on the platform, especially some of those whom I've actually now adopted, and I'm helping out on a daily. Some of them are so independent now, they don't even need me anymore. They only need me when they feel the need to. But they'll only report back and be like, so, well, I'm doing well. I wrote this test, I got 90-something%. No, I wrote this test, I got 100%. One of the learners that I'm helping out, or that I've been helping out consistently, is actually got 99%, I think, in term 1 in grade 11. And then in term 2 got 100, Some others are really progressing and improving nicely. There's a particular learner that I'm also helping out that actually sent me a message. Had started watching my live lessons early this year. Mid-June. And then for the June exam, it actually reflected his performance, and messaged me and said, sir, I actually really improved. And I could see the percentage jump. This was someone who was getting like level 3s and like literally got level 5, I think. So from level 3 in term 1 to level 5 in term 2. Whilst many went down in their performance during from term 1 to term 2, she improved drastically. So now I was talking to her like just not so long ago, and she was like, sir, level 7 is definitely on the cards. And I'm like, yes, definitely. So let's just continue pushing and doing the little work. So please, guys, just do what you need to do, okay, when you ought to do it. Otherwise, we'll see each other. You're really welcome, and have a good one.